The James Webb Space Telescope has just seen something it wasn't supposed to see: galaxies too old, planets too large, structures too perfect, and a signal that is steady, rhythmic, and unnatural. It doesn't fit into any known astrophysical model. This isn't just another discovery. This is a collision between what we believed and what actually is. The James Webb Telescope may have just delivered the most profound warning and invitation in human history. And if it's real, then everything we thought we knew about the universe is wrong. In a series of deep-field observations, the James Webb Space Telescope captured some of the most detailed and breathtaking images of the universe ever seen. But beauty wasn't the only thing hidden in those pictures. In the galaxy cluster known as AEL 2744, researchers uncovered perfectly aligned light points, symmetrical structures forming patterns that do not belong in the chaotic world of galactic evolution. These were not just unusual, they were uncanny. In the spiral galaxy designated NGC 1365, astronomers found motion patterns that suggested gravitational behavior contradicting our most basic and long-accepted models. But it didn't stop there. As the Webb telescope continued its exploration, similar anomalies began appearing across multiple deep space images. The farther Webb looked, the stranger the universe became. Patterns began repeating across billions of light-years, structures showing geometric precision in a cosmos that was supposed to be random, governed by entropy and chaos. Scientists initially tried to dismiss these findings, labeling them as coincidence. But there were too many. They appeared too frequently. They were far too perfect. And slowly, the whispers began to circulate within the scientific community. Maybe we're not seeing randomness at all, but a form of order we simply don't yet understand. Among the many celestial targets of the James Webb Telescope was an exoplanet named HIP 65426b, located hundreds of light-years away from Earth. What it revealed left astronomers absolutely speechless. This planet is 7 times the mass of Jupiter. It orbits its host star at a distance 3 times that of Neptune from our Sun. More astonishingly, it exists around a star barely 15 million years old. By all known theories of planetary formation, this planet simply should not exist. There's no visible protoplanetary disk. There's no leftover material or accretion debris. And there's certainly no gravitational explanation for how such a massive world could form so far out, so quickly, and remain gravitationally stable. Some researchers have now begun to speculate. What if this planet isn't a product of its current system at all? What if it's a remnant of a previous cosmic cycle? A relic from a star system that came before, somehow transplanted, reused, or deliberately placed? For now, there are no answers. Just a glowing world, blazing at over 1,000 degrees, suspended in a system that shouldn't have had time to build it, and certainly not so perfectly. In one of the most surreal discoveries to date, James Webb imaged what's known in astrophysics as an Einstein ring, a gravitational lens caused by a massive foreground galaxy bending the light of another galaxy directly behind it. But this ring, located around the galaxy J418, isn't just any lens. It's nearly perfect. A full, uninterrupted circle of light with mathematical symmetry so precise that even the most experienced astrophysicists were left stunned and momentarily speechless. For such an image to exist, the alignment between the 2 galaxies must be exact, down to fractions of a degree, across billions of light-years. That's not just rare. It's statistically improbable on a cosmic scale. While gravitational lensing is a known and accepted phenomenon, the degree of perfection shown here is raising far more questions than answers. Could this be a hint of some deeper symmetry embedded in space-time itself? A sign that the universe isn't as chaotic as we've always assumed, but instead, governed by a hidden geometry we've barely begun to perceive? But no discovery has rocked the scientific world quite like this. The James Webb Telescope has detected massive, mature galaxies forming just 180 million years after the supposed Big Bang. That may sound like a vast expanse of time, but in cosmic terms, it's virtually instantaneous. According to our current models, galaxies should not have had enough time to grow to these sizes, organize themselves into spiral structures, or produce the intense brightness that Webb has recorded. These galaxies are as large as our own Milky Way, fully formed and stable, at a time when the universe should still have been a chaotic sea of gas, gradually cooling and assembling into stars. This has left cosmologists scrambling to revise long-held theories. Because if these galaxies truly are as old as the data suggests, then our entire theory of how the universe began may be collapsing. The Big Bang, long treated as the bedrock of modern cosmology, may no longer hold up under scrutiny. And as some researchers are now beginning to say out loud, we may be looking at a universe that had a history long before our beginning. In a region far from any known major galaxy, Webb detected something entirely unexpected, a gravitational lens effect in a patch of space where nothing visible exists. No stars. No galaxies. No black holes. Yet, light from more distant galaxies bends, curves, and distorts, as if something massive is hiding there. Astronomers have tentatively attributed this to dark matter, a form of mass we can't see but which exerts gravitational force. But the precision and intensity of this lensing effect challenge even that theory. The distortion is too strong, too localized. It behaves not like a diffuse cloud of dark matter, but more like an object, a structure, with defined mass, symmetry, and edges. Could it be a cluster of dark matter condensed into a shape we don't yet understand? Or is this gravitational echo the remnant of something older, something left behind? Some physicists are now quietly floating ideas far more radical, that this isn't dark matter at all, but evidence of something built, something ancient and invisible, still warping space in its silence. Among the telescope's most controversial and provocative findings is the detection of a massive intergalactic filament, a stretch of galaxies and matter aligned so precisely that it forms a structure over billion light-years long. Scientists have observed filaments before, as part of the so-called cosmic web. But this one is different. Its alignment, its density, and its repeating voids make it resemble a grid, almost like a framework laid across the universe. While mainstream cosmology argues that these patterns are the result of gravitational attraction acting over billions of years, the symmetry here is hard to ignore. The galaxies follow parallel paths. The dark matter clumps at exact intervals. Even the redshift readings from this region display a wave-like regularity, as if the very fabric of the cosmos in this zone was intentionally engineered. Some researchers remain cautious, insisting that human brains are wired to find patterns, even where none exist. But others now suggest that if the universe did have a builder, or if intelligence once shaped it, this would be where we'd begin to see the fingerprints. In chasing answers to the gravitational anomalies, one proposal has risen from the fringes into serious academic discussion. That dark matter, long believed to be invisible and inert, might actually carry information. Not data as we know it, but something deeper. A cosmic memory. In multiple Webb observations, clusters of galaxies formed in arrangements that seem to reflect distant, earlier formations, almost like echoes repeating across time and space. What if dark matter, instead of being random, actually preserves traces of past cosmic structures? What if, as the universe expands, this hidden matter holds on to gravitational imprints, shaping future galaxies based on old alignments? It's an idea that blurs the line between physics and philosophy, suggesting that the universe might not only have a beginning, but also a memory. And if that's true, then every spiral, every cluster, every void might be part of a design far older than we've ever imagined. But perhaps the most spine-chilling finding yet is the one few are willing to speak about openly. During a deep field scan in a void sector, the James Webb Telescope recorded a series of pulses, light fluctuations too regular to be random, too faint to come from any known star. The signals didn't match the frequency of pulsars or quasars. They repeated at exact intervals, then vanished completely. At first, scientists suspected an error, a reflection, interference, even a processing glitch. But after running the data through independent systems, the pattern remained. The origin point showed no stellar mass, no nebula, no heat signature, just a steady flash, precisely timed, as if measured. Or perhaps, timed. For now, NASA has declined to comment. But behind closed doors, researchers are asking a question that has echoed through observatories and lecture halls for decades. What if it's a message? Not meant to be received, but simply noticed. And if so, who, or what, was meant to see it? The James Webb Space Telescope was built to reveal the past, to peel back the layers of time and show us what the universe looked like billions of years ago. But in doing so, it may have revealed something even deeper, that we are not just observers of the cosmos. We are part of a system far older, more precise, and more deliberate than we ever imagined. Galaxies